All right, so let's talk about how to find an inverse of a one-to-one function. We said in the last video that a function has an inverse if it has a one, or if it is one-to-one. It's one-to-one if it passes the horizontal line test. Um, so assuming we can find the inverse of a function, how do we do it? So here are the steps written out. We'll talk about these as we go. Let's find the inverse of this linear function. And like I said in the last video, all linear functions will have an inverse. And so the way you do it is just make that a y. And now we're just going to solve this equation for x. So just bring the 2 over. That equals 3x. And then we'll divide by 3. So y plus 2 over 3 equals, and so that equals x. We'll go ahead and put f inverse of, actually, we'll leave it as x, and then that implies f inverse of x, and then we'll write this with an x. So even though this is technically the set, this is the range. What numbers would go in for x here would be the range in the original function, which is y. You still write this with x. So just always write, whenever you write the answer, write it with x. And some books will tell you switch the x and the y before you start. So write x equals 3y minus 2. It doesn't really matter as long as you solve for whatever variable you have that's not by itself. Get that one by itself. All right, so that one should be pretty easy, solving for the linear equation. This one might take a little bit of practice to get where you can do it quickly and easily, because it's not, I don't think, super obvious the first time you see it where you would go. Usually when I teach this in a class, I will not tell them what to do. We'll kind of work through it, and I will make someone just suggest something. So sometimes doing something that you know to do will help, even if you're not sure if it's the right thing. But let's see how this goes. So let's write this with the y. So y equals 2x plus 3 over x minus 1. And basically, so this is a rational function. In most rational functions, when you're finding the inverse, maybe all of them, you kind of do the same steps. So the first step is to cross multiply. So let's get xy minus y. Just multiply y times x minus 1. That equals 2x plus 3. And now this might be where you might get stuck. So one thing you might say to do, factor out the y, but that doesn't really help because the y was already factored out. You kind of already, unfactored it, you distributed it. So factoring out the y is not the right next move. So what is the right next move? You want to get the x by itself. So don't ever forget your goal. And as we get further into this course, we do problems that might take a little bit longer. Don't forget the goal. Don't forget what you're trying to solve for. What's the ultimate answer to this problem? And the ultimate answer to this problem is to get x by itself. So let's get the x terms on one side, get the non-x terms on the other side. So let's bring the 2x over, and we're going to bring the negative y over to the other side. So we have xy minus 2x equals y plus 3. So we just bring this one over, and we bring that one over. So now we have the x's on one side. And now it might be obvious. Now we can factor out the x. And now we can divide by y minus 2. And we get x equals y plus 3 over y minus 2. And if we want to write with correct notation, we'll write it like this: x plus 3 over x minus 2. And so that's it. So that's pretty much the same steps. Any rational function, you're going to have the same steps. So if you even need to, go back and you can write down the exact steps we did as we went through this. So cross multiply x terms on one side, non-x terms on the other side, factor out the x, divide by the factored out part. And there you go. All right, so next we'll look at graphs. So how do the graphs of inverse functions relate? So if f of a equals b, then f inverse of b equals a. That's switching the x and the y. Now, one way we could say this is the point AB is on the graph of f if and only if the point BA is on the graph of f inverse. So they have the exact opposite ordered pairs. And the way it works out is these two graphs are symmetric around the line y equals x. So they're symmetric around that diagonal. And so we have AB on the original function. That means we have BA on the inverse function. And so if we plot all the ordered pairs, this is kind of what it looks like in this particular case, but it's always symmetric around this line y equals x. So this problem, sketch the graph of f of x equals square root of x minus 2 and its inverse. And so we talked about transformations recently. And so how is this one translated? So the square root of x, you should know, just looks like that. And so how is this translated? It is translated 2 units to the right. And so let's plot a couple of these points. So 2, 0 would be a point. What about when x is 3? That would give 1. And we won't do all of these because you cannot take the square root of all of these, or at least it'd be kind of ridiculous to try to plot them all. The next one we could do would be 6, and that would be at 2. And let's see, that's the last one we can do there. So there is that graph. So now what does the inverse graph look like? Well, you can plot we have 3 ordered pairs, and also you can kind of get an idea of what this looks like based on what would be the inverse. What's the opposite of a square root? The opposite of a square root is a square. So the inverse of this function must be a quadratic. So just keep that in mind. If we have 2, 0 on this graph, that means we have 0, 2 on the inverse. If we have 3, 1 on this graph, that means we have 1, 3 on this one. And if we have 6, 2 on this one, that means we have 2, 6 on this one. And you can see it looks like that. Now, this is a quadratic, but it doesn't mean it comes over here, because if you make it come over here, it's no longer 1 to 1. So if you draw this part up over here, you can have a horizontal line that cuts through twice. Also, remember the domain and the range of f of x are the range and the domain of the inverse. So the domain of, we'll make a little table here, f inverse, and we have domain and range. And so the domain of f, remember we say x minus 2 greater than or equal to 0. We can also see from the graph here, the domain is 2 to infinity. So that means the range of f inverse is 2 to infinity. And the range of f is 0 to infinity. So that means the domain of f inverse would be 0 to infinity. So 0 because the x is 0. And so that can help also when you're trying to graph this. But you can also find the inverse and then graph the inverse, as long as you might want to pay attention to this part. So let's find the inverse. So we have y equals square root of x minus 2. We need to solve for x, so let's square both sides and bring the 2 over. And so we get x equals y squared plus 2, or let's say f inverse equals x squared plus 2. So really all we're doing from here to here is switching the x and the y. And if you remember from the transformation section, the plus 2 moves x squared up 2, and then of course we only have half because of how this one is. And you can see symmetric around that line y equals x. All right, So if you have any questions, feel free to email me and let me know, and we'll get those taken care of.